In Chapter 2, we're going to look at atoms. And right now, we're going to look at atom structure. Before you go any further, open your book to the inside front cover, and you'll see a periodic table. Any time that we start using atoms, you're going to need to use your book or use your a periodic table. You can either open your book or you can get a copy of a periodic table so you can use it for information. The atoms are made of subatomic particles, electrons, protons, and neutrons. You need to know that electrons are negative, and we consider them to have no mass. They do have a little bit of mass, but it's very tiny, and it's only 1 over 1800 AMU. AMU is atomic mass unit, and it's just a unit that we use when talking about atoms and subatomic particles. You don't need to know anything else about it. It's has a very tiny mass, and so we usually ignore the mass of electrons in anything but the most precise calculations, which we are not going to do. So just say electrons have no mass. There are protons, and they have positive charge and a mass of 1 AMU, and there are neutrons that have no charge and a mass of 1 AMU. So understand that atoms are made of these 3 particles and know their characteristics. The most important characteristic of the subatomic particles is their charge. This is what gives structure to the atom. Like charges repel and unlike charges attract. That means electrons are repelled by electrons, protons are repelled by protons, and protons and electrons are drawn to each other. The neutrons have no charge, but they're held in the atom by some strong forces that have nothing to do with charge. The structure of the atom is that there's a proton, or any protons and neutrons are in the center in a place we call the nucleus, and the electrons are in a cloud all around the nucleus. Because protons and electrons have opposite charge, all the protons in the nucleus have this positive charge that pull on the electrons, pulling them into the nucleus. But the electrons can't, well, one might, but the electrons do not fall into the nucleus. The electron repulsion, as they start coming into the nucleus, they start repelling each other and keep them from getting too close to the nucleus. And then 2 atoms adjacent to each other, the electrons are on the outside, so when 2 atoms collide or rest next to each other, they have these electrons that push the atoms away. Now, we're going to talk later on about attraction between atoms. We're going to ignore that for now. Just realize electrons won't fall into each other because the electrons on the outside are this repulsive force. And the atom itself has electrons being pulled into the nucleus, but they can't come in too far because the electrons start pushing away against each other. So here we have an element, lithium. What is it made of? Little individual atoms that we consider to be like little balls. Okay, those atoms then are made up of what? This is the nucleus right here. Of course, it's very tiny. Extremely tiny. We can get kind of an image of atoms under an electron, an electron tunneling microscope, and we can find the electrical field of these things is basically what happens. And they do look like little spheres, but nobody's ever seen inside an atom. We just imagine that it looks like this. We really don't know what it looks like. So here would be the nucleus, and it's extremely tiny. We show it as being rather big, but if an atom, let's say an atom is maybe 4 miles wide, the nucleus would be probably about 6 inches wide. So it's very, very tiny. And then around that nucleus, what do you have? All the electrons in a cloud. Now there's structure to the electrons, but we're going to look at that in a later chapter. Right now we just want to get a general idea of the atoms. So How is it that the atoms differ from each other? Well, the atoms differ from each other in the number of protons and electrons and neutrons. The number of protons, though, is most important because that gives the identity to the atom. It tells you what element it is. We call the number of protons the atomic number. Well, atoms are neutral, so if we know the number of protons in a neutral atom, the number of electrons have to be the same. Because protons have a positive charge, there must be an equal number of negative charges in there. So in a neutral atom, the number of protons is the same thing as the number of electrons. These proton numbers are very stable. The only way they can change is by a nuclear reaction. So if we have a sample of carbon, it remains carbon because the number of protons in each atom stays the same. If you have a nuclear reaction, that can change, but we're going to look at that later on in this chapter. So when we look at the periodic table, you will see there is a whole number there. That is the atomic number. So lithium has a whole number 3. It has 3 protons in it, and of course 3 electrons. The number of neutrons we'll go into later. In carbon, it has 6 protons, a atomic number of 6, and so 6 protons, and so it has 6 electrons also. So now what I want you to do is find the atom in the periodic table that has 14 protons. Okay, well, if you look, you're going to see that it's silicon. Which one has 8 electrons? Well, because an atom with 8 electrons must have 8 protons if it's neutral, it has to be oxygen. Okay, so now this is the end of this little bit. In the next lecture, we're going to go into the number of neutrons.